right, hello everyone. My name is Jason Molgaard, and I'm a Storage Solutions Architect at ARM, and I'll be moderating this afternoon's panel, Security Impacts to a Changing Storage Ecosystem. So I'd like to introduce the panelists to start with. So we have three panelists on our panel today. Eric Hibbard, who's the Director of Product Planning at for Storage Networking and Security at Samsung. Walt Hubis is the Principal Engineer for Industry Standards at Micron Technology. And David McIntyre is the Director of Product Planning and Business Enablement, also at Samsung. So we'd love to answer your questions. That's the whole point of this session. So please submit your questions via the Q&A button on the Zoom window. You'll be able to see our other people's questions, upvote them, downvote them, whatever you want to do, so that we get the questions up to the top and we can get them answered in this session. And we'll try to get to as many questions as we possibly can. You can also post questions on Slack. We're monitoring those channels as well, so that we can make sure that your questions get answered. We do have some questions already canned that we'll start with to try to get the conversation started, but we really want to answer your questions and look for an evaluation at the end of the summit to evaluate this. And then, of course, if you want to know more about compute, memory, and storage, you've probably seen this slide before in one of your other sessions, but lots of ways to connect with SNIA and with and the Compute, Memory, and Storage Initiative. So find one that works best for you and join us and find out more. All right, I'm going to stop sharing so we can see all of our panelists and start asking them some questions. So our first question is, are applications running in the drive going to fundamentally change the threat landscape for this technology? So I don't want to necessarily call on anybody, but maybe it'd be easiest if I do. Eric, would you be interested in taking this question first?
Sure. I had a sense that it would be coming my direction.
They're all going to come your direction.
So yeah, this is a really interesting question in the sense of I'll give you the lawyer answer. It depends. My speculation is that it may take a bit of time before the normal attackers sort of figure out that this capability is there and then begin to try and exploit it. So it may be fairly unmolested in the early stages of the technology, but later on I think it's gonna be a target if it really takes off. One of the things that I find really intriguing about this, because I do, in the past, quite a bit of work with IoT, and this seems like almost a natural to sort of enhance the intelligence around IoT, when we talk about edge and whatnot. And IoT is a source of a lot of concerns for the security community right now. And so this just adds to or potentially builds on that. So I think in the end, if this is successful, which I think it probably will be, the IoT activity is going to be a fairly dangerous space. And I think we're going to see a lot of security issues that we'll have to deal with coming from that community.
Yeah, I would really second what Eric's saying there. One of the big things that you have to keep in mind with this change coming down is that typically disk drives are purpose-built. They're designed internally for to store storage securely, or to store your data securely on the storage, whatever your storage media happens to be. And now what you're doing is you're taking this very purpose-built technology, both in terms of hardware and firmware, and now you're injecting in something that's general purpose. You can now download a program into this device and have it run. So you have a brand new infrastructure there. And I think whenever you have a new infrastructure, you tend to open up more threats. You open up more vulnerabilities in the products that you build. So it's a mind shift. It's really going to have to be a mind shift on the part of, I think, the manufacturers, and also going back up the stack in terms of how the people actually writing the drivers actually approach this.
So there's if you look at the models that are available in computational storage, there's a number of them. Two example ones would include functional download, where you're offloading a portion of the application down to the drive. And another model would be where you're actually running the entire application on the drive itself. In both cases, you're adding a compute element to do so. That can be integrated within the controller. It could be an adjunct ASIC or acceleration device. And in both models, you're basically introducing a new component that can introduce exposure points in a threat analysis. So both the ingress and egress, the compression, decompression of the data, as it enters into the compute resource, does add additional security challenges that need to be considered. I think we're early on, it's still an emerging technology, even though the market is waiting, where there's an opportunity to get ahead of the problem before the problem gets ahead of us.
Yeah, that's an interesting comment. And as a practicing security professional, I got to tell you, I have a lot of concern about this, in that I don't think very many security professionals are even aware of this technology, and we've got to figure out how to get them engaged. I know we're having some conversations within SNIA and IEEE about how to deal with some of these topics in, for example, the ISO storage security standard. But right now, it's just not on their radar scope. And as I think back on how they responded to things like cloud computing and virtualization, they had very different responses. In the case of cloud, they got pretty freaked out and chased it very quickly. In the case of virtualization, the available resources in that space are pretty thin, and so we really don't know how or if they'll actually engage on this topic. And I agree that we're going to need their help over time, but right now is a real challenge to figure out how to get them to engage.
Yeah, I appreciate that insight. That makes a lot of sense. I think obviously we are going to have to get a lot of traction going there for security and computational storage to be successful and secure. What about from a supply chain perspective? Does computational storage fundamentally change how the supply chain situation is handled?
Oh, not to mention solar winds, but
Yeah.
oh wait, I just did.
Right, exactly.
So if you had any doubts about concerns in that space, that pretty much changed the game. We talk about black swan events in the security world, and that's clearly a black swan event. So from a computational storage perspective, we absolutely have to factor that into everything we're doing going forward. We have to assume, as vendors that are operating this space, that if we're the suppliers of the apps that are basically coming down, we're going to have to work hard to make sure that there's no injection. Equally important, that somebody can't override whatever you're putting in. So where are the trusted sources of the code coming from? How can you verify it? These aren't necessarily unknowns right now. I mean, we deal with this kind of thing with firmware downloads and whatnot, but given what happened, earlier, late last year, the stakes are much higher for this activity. And that's going to be one of the things that the security community, when you get them to engage, I'm sure they're going to start with discussions around, so how do I really know I can trust you? And how do I know I can trust your code? And, it's going to go from there.
Yeah, I'll jump in on this. So if we look at the device level, many of the computational storage solutions out there today use FPGAs, which have the ability to be programmed in the field. However, there are security mitigation or security robustness improvements that have been made over, say, the last 10 years, actually. So you're able to quarantine specific sections within the FPGA fabric that could be more risk prone, both in the, as you were mentioning, Eric, in the, if you were uploading an application and you wanted to have a higher level of security in your scheduling, in the compute resource that could be on the FPGA or any of the other hard macros within the FPGA, you have a means of protecting and containing the risk is the best, maybe the right way to consider it. Yeah, so that is one way of controlling the application flow. Yeah, I'll leave it at that.
Yeah, if I can. Oh, go ahead, Walt.
Yeah, and I was going to suggest too that, you know, like I said, most of the vendors have really secure methodologies for getting firmware into the drives and so forth, and we've learned through hard experience about how to control that chain and how to assure this. Now, this is going to be a little bit of a different mindset now because we have these general purpose applications that are going to be downloaded from wherever. I think there's going to have to be some kind of a close participation between the people that are actually writing these programs that are going to be downloaded and executed on the drive with the firmware vendor with the drive vendor, for the SSD or whatever you're talking about here. The issue being they've got to be able, number one, to assure that that program is going to operate correctly on the device and not cause a lot of other issues. And the other thing too, of course, is the security. They're going to have to work closely with the drive vendor to assure that the supply path is secure all the way down to the drive. And when we start talking about sourcing these various things, it really mushrooms out, because now not only do you have the folks that are actually writing these downloadable programs, but you also have all the supporting firmware. A lot of time it's from third parties or from other entities. That now you've got a pretty broad supply chain here funneling into a particular device that holds all of your data. So I think there's going to have to be a fairly high level of cooperation between vendors and actually people attempting to use that computational storage.
So it sounds almost like like we see with Apple and Google with their stores. So there's some level of vetting.
Yeah.
You know, I wanted to actually bring up another point that David kind of caused me to think about is, so let's say that one of the apps that you end up downloading into one of these drives is encryption, because it's running an FPGA, so it's probably going to be faster than if you're doing a software implementation. One of the things that we've got to be careful about is, so the app itself might be fine, but as you're probably aware, another malaise that the security community is dealing with is ransomware. And the last thing you want to have is, okay, so you've got this awesome tool that you've downloaded into the drive, and you know, somebody's figured out how to turn that tool against you, and that's an area where there's a lot of concern. So for example, when we are looking at things like data reduction techniques and encryption, we want to make sure that their use can't be easily exploited by the bad guys, so to speak. So it's not just a matter of, do we trust what we got loaded, but do we have enough controls on it that only the systems that are supposed to be invoking it are in fact invoking it. And that's that's part of an interface, and in the security world, we always tend to inspect all of the interfaces, because that could be one of those sort of weak links that cause a problem. And so again, you know, I'm anticipating that the security community will probably be looking at ways, especially, you know, you mentioned encryption. They're thinking malware. You know, is this a new weapon in that space?
There's actually, and I'm just learning about this, is FHE, fully homomorphic encryption, which my understanding is you don't have to decrypt the data. You can compute unencrypted data. And I know it may still be a research topic, but it's quite interesting, right? That might provide some further defense.
Yeah, I see Walt smiling. He knows that. So I chair Insight's Technical Committee CS1, which is basically the U.S. committee going into the ISO dealing with information security. So yeah, there's work group 2 is just starting some work on homomorphic encryption. It's sexy to talk about, but the applications that you can use are fairly limited, because you're at the end of the day, you're dealing with ciphertext. And depending on the algorithm you use, there may not be, you could have the same file 17 times, and they may all be different. On the other hand, you pick a certain algorithm, the ciphertext may be identical. And that's the kind of thing where, depending on how you did it or inside of a database, you may be able to key off of the fact that, oh yeah, if I see this ciphertext, I know that it's $100,000. And how many times do I see that in the database? So that's an example where you don't really need to decrypt. You don't really need to know that it's $100,000. You just need to know how many instances of it existed. So it's kind of cool, but yes, it's not a replacement for if you need to actually look at the text to be able to deal with searches and things like that. It won't save you there.
So Walt, you were smiling. Did you want to add anything? That was.
Yeah, I think we were looking at homomorphic encryption 10 years ago, and the general. I haven't looked at it recently, but I don't think it's gone very far.
No, a lot of getting the applications configured to essentially be able to exploit what it offers, I think, is part of the challenge.
It's difficult. Yeah, it's difficult to implement.
It feels like it would be limiting in terms of the applications as well.
Yes.
Yeah.
I mean, what I've been seeing is it shows a lot of promise from a database perspective, because then you can use almost like an index, if you will. So you don't have to do it's back to, you don't need to decrypt the data as long as you know this is what I'm after. Yeah. But then again, the algorithms you're using might not be the ideal ones either. The ones that, like ECB, the mode kind of leaks information as well. So
makes sense. All right, well, let's move on to another question then. This one's kind of related, or is very much related, I guess, and certainly we're not going to have all the answers, but for application developers, how does one ensure that the app is going to securely reach the drive? Do we leverage a lot of the existing technologies? Does something new need to be invented? Well,
it's a very similar thing to what we had talked about, earlier, that, we have methods in place right now that will allow us to really securely deliver the firmware to the drive. And I think, it's as long as you're doing all your development and so forth in a secure environment and have the right mechanisms in place, it's pretty straightforward. But yeah, this is the kind of thing where the drive has got to have some kind of a root of trust that can go back to what the developer's doing as well. So that really, no matter what you do, at least at this point, you're kind of dragging the systems vendor, the drive vendor, into the process to help assure that the necessary endpoint is there in terms of security to be able to assure that security all the way down. Right, and one of the issues here is now is if you think of private public key kind of key pairs and things like that, that implies you can have some pretty close relationships between actually implementing the code you want to implement to run in the drive and the drive vendor. I think I'm still looking for a way to get around that and to keep everybody secure, but I haven't gotten there yet.
Yeah, I agree with everything, Walt, that you just said, and I guess the thing I would add to this is, again, this is not a new problem. I mean, we've got this with firmware, and I would simply point out that if you've been tracking some of the European activities, shall I say, Lot 9, which is if you're involved with sort of green storage, green servers, basically they're encouraging reuse of technology. It hit us recently with the secure data deletion, but the new thing that's hitting is dealing with this whole firmware issue and dealing with it. So I think by the time this is sort of front and center for us, depending on what happens with this European regulation that's kicking in the not too distant future, it will be relevant to these products.
So just to add to what Walt was saying, you can assign a specific drive to a specific customer. and have some user identification protocols put in place. So there is a containment option there. Another, which the cloud service providers are are addressing today, it's part of their security policies, is how to deal with multi-tenancy, right? So you can put a drive or an array of drives in a container and have some policy on, do you allow multiple tenants to access the compute and storage resources within that particular container? But certainly having those policies are a means of further adding a further layer of protection.
Yeah. That working with the individual with vendor-specific devices, for example, is something that's really common throughout the industry. The only issue I'd bring up, David, with that is now we're talking about many smaller organizations coming into play here. So, like I said, I'm not saying it's not doable. You have things like some of the supercomputing guys. Think Los Alamos or some of those other ones. They're small. They're small in terms of drives they buy. They're not a lot, but this is like God's gift to them. And so the issue that we have is how do you now switch from where you're dealing with a couple of big OEMs to now you're dealing with a whole bunch of smaller folks that really find value in this. Not sure how that works yet. That's kind of the business side of it that I'm curious about.
So it's not, and right, it's not just the OEM side; it's the customer side too.
Yep.
Right, the user side that
end users
want to run their applications. Yep, exactly.
Great, I agree. Makes sense. So we've kind of talked about some of the standards, but maybe we can kind of do a survey of the state of the standards relative to these new technologies. So where is the work happening for security across the community?
So at least from a security and privacy perspective, what we see are a fairly large number of projects are handled at the international level. So and I apologize in advance, but there will be an acronym check later. So if you're dealing with ISO/IEC, JTC1, which is basically a joint technical committee between ISO and IEC, which are two of the three biggies in the international standard space. Subcommittee 27 does information security, cybersecurity, and privacy protections. All right, so that subcommittee last check, which was about a month ago, has about 310 documents. So that's approved standards, draft standards, core agenda, which are patches, and amendments. And then from there, you step into the domestic space. So almost every country in the world has its own set of standards. So like in the US, you would look at NIST, but they're not the only ones because NIST doesn't cover everything in the US government. And by the way, NIST is not they're not the US standards body. That's ANSI, and of course we're all volunteer standards. So then there's lots and lots more, but there are other players that are, ITUT is actively involved in security. IEEE has got activities in this space. The list goes on and on and on and on. And of course, there are all kinds of organizations that are developing specifications/standards depending on whether you're a purist or not. So in the case of some of the work that SNIA is involved in, obviously SNIA does some work. They're working with DMTF, they're working with NVMe Express, they're working with the Trusted Computing Group. I'm sure OCP is in the middle of this. JEDEC. You see, by the way, there is a quiz later for
I mentioned that at the beginning that there was a quiz.
Yeah, there's a lot of organizations that are plugged in here. I know from an ISO perspective, there's a particular document that's important to the storage industry. It's ISO 27040, which is focused on storage security. In fact, some of us were on a call just a little while ago. I'm the ISO editor for that project, and it's actually a revision, but it gets into the nuts and bolts of technology, down looking at how do you secure fiber channel, how do you secure NAS systems. And some of the conversations we're having right now is it too early to try and even specify guidance, if you will, around things like computational, storage and whatnot. And we're in a bit of a race condition in that ISO standards take about 3 years to develop. And so there's a possibility that if the computational storage specs are published in the fairly near future and security guidance emerges on that, we could actually see some early bits of that showing up in the new ISO standard, which from my perspective would be good, because that's a quick way to clue the security community into, oh, look, there's something new here you should be paying attention to.
So yeah, I do know that SNIA's got, at least as part of their computational storage group, is they have a security subgroup basically for computational storage, where a lot of that work is starting to engage now. And interestingly, there's work going on in NVMe related to computational storage as well. Although so far there's not been a lot of discussion about security there. Having said that, there's already some amount of security that's inherent in terms of what's going on, for example, with PCIe. Now having a secure PCIe bus, there's all kind of stuff going on right now that's more at the channel level, that's taking care of some of the security concerns that we have. Eric was talking about some higher level specs, and what's really curious to me, and I'll just throw this out for the discussion, is, boy, gee whiz, I wonder how this is going to affect FIPS. And how now do you certify a storage device for the Federal Information Processing Standards?
Actually, well, add to that we just moved from FIPS 140-2 to FIPS 140-3, so the game has changed a little bit, and might as well throw common criteria in this loop as well, because if you're familiar with common criteria, or in the ISO world is known as 15408, the new version of common criteria is about to be published out of Subcommittee 27. We're expecting like in the next couple of months on that. And it went from a 3-part standard to 5-part. So if that weren't bad enough, so we're looking at a fairly new technology. Now, what I find fascinating about FIPS 140 is it's all about how you define the crypto module. And so if you are able to basically say, what we're certifying, it's just the crypto chip or the FPGA, and as little as you can get away with in terms of certifying, then you've got a pretty good shot. What typically doesn't happen is you don't end up having to certify the whole device. Historically, the vendors with FIPS 140 really shrink down exactly what's being certified, and of course somebody who's operated in the data center space, it means you actually got to go read what's been certified, so that so it actually has some meaning. This was one of the problems with common criteria, which is a more broader coverage of, so you might actually have the whole device get common criteria certification. That's the good news. The not so good news might be the only thing covered was the network connection, and nothing to do with any other part of the security. Maybe not the encryption, maybe not the media sanitization, none of that stuff. So the devil really is in the detail on some of these certifications, and so you can navigate them. As vendors, as consumers, you absolutely have to look at specifically what was certified to make sure they pass your maybe your giggle test, as opposed to what the vendors are trying to do.
So there's a layman's higher level view also to contribute here. So I'm drowning in the alphabet soup, and I would say that Walt, you mentioned the subcommittee for computational storage, part of SNIA, which is beginning to get revitalized, and then. Right, so there's a computational storage technical working group that is building out the architecture spec, where security elements will contribute to that. Then it becomes challenging, because you've got, those are functional specifications that the vendors agree to, more or less. Then you have to deal with the application developers. to show them these are the preferred security solutions with these types of components. And then the wrench is with the hyperscalers, because frankly, they don't all the time participate in these committees. They like to do it themselves and do it secretly, and that's how they sustain their competitive advantage over one another. So I did allude to, but they do have their own policies. So there's a tremendous amount of moving parts here, and I think there's also a tremendous amount of opportunity to educate the application developers and provide an advisory or consultancy that helps them navigate all these security standards that they should be aware of, without diluting all the good works that are done, but at least show them a path across all these three-letter acronyms.
Yeah, and sort of piggybacking what you were just saying, the way some of these ISO standards come into play is they're the things that regulators are looking at that are forcing the cloud, for example, cloud service providers, they have to address some facet of this. So there's this sort of interesting sort of trickle down, but there's also this sort of building up. I would say what we're trying to do in the storage industry, and I know Walt and I are heavily involved in these activities, is we're trying to make sure that we're looking cradle to grave across the security issues in sort of the storage arena. We want to make sure that there aren't any major gaps. So both of us are watching and trying to contribute where we can on the computational storage aspects, but talking about the threat modeling and what's new here, what's not new here. But when I was talking earlier about things like ransomware, that's really out of the bailiwick of what the SNIA computational storage activity can really kind of get into. On the other hand, if they're aware that this might be an attack vector or an attack that could happen, it's like, well, are there things that we could do that might make it easier to block that kind of thing? And things like hardware roots of trust play into that. And so, that kind of discussion is like, well, geez, we should probably try to make sure that that's factored into our designs and the specifications, because it helps sort of mitigate that. Where if you didn't know that kind of stuff is going on, that's an extra cost. Don't do it.
Well, you had mentioned the cradle to grave aspect of this, and the cradle all begins with the development community. I just got done with spent a couple of years doing as an architect, a security architect for one of our products, and I'll tell you that the real core, the real root of this goes back to the development process. Whether your developers are developing downloadable code for a device, whether they're developing transport mechanisms, whatever it is, that awareness of security throughout the development organization and make it an important part of the deliverables that the engineers are responsible for it underlies all of this. So without that, you're not going to get security. You may get security later on, but at a substantially higher cost. So I think that's one of the real root things we got to be aware of here.
Bolting on security after the fact almost never works, especially when you're talking about things that are sort of core. And I would agree, Walt, having worked for another storage vendor in my past, I spent a lot of time essentially teaching the engineer. Teaching is not the right word, but exposing them to the concept of sometimes engineers can be a challenge. Risk. The concept of risk. And they used to talk about use cases. And I always walked in and said, abuse cases. You just brought out this gold-plated shiny hammer. And I'd say, you know what I'm going to do with that hammer? I'm going to take it and I'm going to beat you with it. So what did you do to keep me from doing that? And they're like, well, why would you do that? Well, because I can. And we have that really interesting conversation. And then that mindset sort of flips, and they're like, well, okay, so, geez, what if I knew something about this implementation? What bad things could I do? And then you start getting some interesting reactions from the engineering team, like, well, geez, because in some cases they might even choose different kinds of technology options once they start thinking about the risk implication. The other piece is the maintainability and supportability. This is a huge issue. And we're concerned about this in the IoT space. Is you put something in the wall that's going to sit there for 30 years. How long are you going to be able to patch that as a vendor? Are you going to be babysitting that for the next 30 years? I mean, how much IT do we have in the data centers that are 30 years old? Not that much, right? So that's another facet of this, is the choices you make, the designs that you have. Is it engineered in such a way that you can update it? Or there's a professor at Georgetown, Professor Ohm, and when he talks about IoT, he talks about being able to lobotomize the IoT such that you can't patch it anymore, and it's become so insecure, it's a source of attack vectors, that you're able to basically disable it, but its core function remains, in place. So think of a smart light bulb. So the security on the smart light bulb has become a liability. You want to be able to basically nuke that, but you want the light bulb to work as a light bulb. So if you think about, and that's a really simplistic model, but if you think about what we're doing with things like computational storage and some of these, sort of advanced techniques, are there things that we can do there where if we can't patch it and it's become a liability, is there a way that we can turn off the smartness so that the smartness isn't basically a tool against us? And those are things that aren't necessarily easy to specify, but developers need to be thinking about some of these kinds of things.
From an end customer standpoint, when you bring a new technology into play, especially in the enterprise realm, you're introducing fear, uncertainty, and doubt. And I commented earlier that the architecture spec, as an example document coming out of SNIA TWG, it is just that, it's a functional document. But I think there is an opportunity for the vendors to embrace that functionality and then compete with specific solutions and come to the forefront with either device or subsystem level solutions that will remove that FUD, that fear and uncertainty, to doubt, or at least mitigate it as a competitive opportunity. Because as both of you have said, unless you bring up security at the beginning, Eric, you said this, it's hard to bolt on at the end.
Yeah.
And so I think there from a marketing standpoint, there is an opportunity to address security here. Perhaps along the lines of whether it's IoT or consumer phones, which are now IoT devices, right? They already have their security mechanisms in place. So maybe it's a means of adopting similar mechanisms in the enterprise world with computational storage.
Yeah, that's exactly where I was kind of headed with that, Dave. That's a great point. As you move forward, one of the real keys to innovation in this is going to be, we need to do this. We need to have a way to securely get this code down there, make sure it works, make sure it's not malignant in some way. Mm-hmm. But what's really important is for the developers and for the supply chain, how do you make that easy? Right? Difficult security is not very useful. Something that's easy to implement and you can do relatively easy, I think would be a great differentiator among vendors of this technology.
Yeah, I mean, the mantra that you hear both in the security community now and the privacy community is it's by design. So it's security by design, privacy by design, and privacy and security by default. So it's not that you've got to get the elephant and the lion to jump through fiery hoops just to be able to turn on. It's like you want to be in a position where if you don't want it, you got to turn it off. But it's an active, it's an action that you as a consumer, whatever the technology is. And again, that's another facet of the conversation that has to take place with the developer community, is they need to understand that this stuff needs to be there from the start. And sometimes security can be Well, we've never seen it function as bottlenecks. Just think about firewalls and choke points and things of that nature. So it does require, when you know it's going to be on from the start, then that may actually cause you to think a little differently about how you do your design and certain technology choices. But this security by design is absolutely critical in this day and age, because if you're not doing that, your product is not going to make it into most of the the critical infrastructure and most of the market sectors that we're probably targeting as an industry.
Well, I definitely agree with that. The security by design or even privacy by design, those make a lot of sense. And I don't think it is going to be successful without that. So kind of related to this, and I think, David, you had kind of touched on this briefly, with so many different security bodies that are considering standards, how does small players get engaged and get informed? A lot of the computational storage startups that have been participating in the PM+CS summit over the last couple of days, they're small companies, they're startups, and they're innovating great new ideas. But how do they get engaged with all this stuff?
I think small startups, for enterprise solutions, for the most part, to get some design traction, we'll look to partner up with larger companies, either for investments or for introduction to customers themselves. So I would suggest that the bigger companies that these startups decide to partner with need to shepherd these startups for things that they may not be aware of, right? So, Eric and Walt are very versed in the subject and have both worked for large corporations where they have the luxury to spend the cycles and the time to become experts in this area. Whereas startups, you're focused on your burn rate and getting a specific product out the door as quickly as possible while raising enough funding to do so and capture some lead customers. So I think the parent company or the seed investor from a strategic corporate standpoint can help shepherd some of those security requirements that perhaps the startup companies aren't aware of.
Well played. You danced through that nicely. I think we were all looking for the foxhole on that question.
Well,
All right, well, maybe we can move to another question unless you have anything else you want to add.
I was going to say there are resources out there. I mean, do you need to be on the bleeding edge? Well, probably with what we see with computational storage right now, yeah, probably. It's right on the bleeding edge. It's going to be difficult unless you're unless you're a member of the standards organizations, which is expensive and is time consuming. I know this intimately. One of the things that you can do, though, is there are things like SNIA. SNIA is not, for most cases, isn't all that expensive, but there's also a lot of stuff, a lot of information that's available through things like some of the government standards. NIST is a great example of that. There's a ton of stuff there, and it doesn't cost anything. There's a lot of information on the web. But again, when you're developing a new product, if security isn't one of the items that's on the list, right, you're going to miss the boat.
Yeah.
If that security, when you drive it into a product, it's going to have a cost, and it's going to have, time associated with it and so forth. And sometimes it can be deferred in the case of prototypes. But the key thing, again, is once you go into production with a product, you better have the security built into it.
Yeah, I'd like to piggyback on what you're saying, because I do a fair amount of work with the American Bar Association. So I mentioned I do some IoT. So I'm a co-chair of the ABA's IoT committee. That should just scare the hell out of you, that lawyers are that interested in technology. But that said, if you are a large vendor and you are shepherding one of these organizations, through the manufacturing process, and you may be actually rebranding it, lawyers are watching. And if you've not done your due diligence as the big company and helped the little company to do that, you're going to be accountable. And and it's not, pocket change that's happening here. There are law firms out there that have huge security staffs on board. They are actively looking at vendor products and filing injunctions against vendors. Now, I wouldn't say that part of the reason for doing that is they're trying to recover, the cost of keeping their security people busy when they're not doing like e-discovery or forensics and whatnot. Oh yeah, they might be. But, this is one of those situations where assume that the legal community is going to be looking over your shoulder, and they may not go after the little guys, but they will go after the deep pockets. And so this is something to pay attention to. The regulators had a little bit of quality time with the FTC. Unfair deceptive practices is a pretty broad arena for them to basically go after you. So if you start making claims about your product is secure, that is like the worst thing you could possibly say, because all they got to do is show, oh wait, you had a vulnerability, you knew about it, you didn't tell your customer. That could be good for $600,000 fine. So back to if you're dealing with the little guys, and you're one of the bigger guys with the deep pockets, you absolutely want to be paying attention to what you're doing here, because it can bite you.
Yeah. So to add to that, we're getting into a legal discussion. I didn't expect that, but the big guy also not only has that role of shepherding the little guy, because like you explained quite well, the little guy doesn't have the pockets to be of interest to the lawyer who's looking to get some return on his investment his time. And so, but certainly the big guy that's has some indemnification that's capped. Those are the sorts of situations that provide exposure points that the lawyers like to take a look at. But that's the reactive part of this. The proactive part of this would be, as we know, drives go through qualification cycles, and perhaps what's needed is to add this security level of certification that can be added within the qualification cycle before that drive is certified for use.
Yeah, I would agree completely with you. I'd also add, if you've got a technology lawyer that you are familiar with, there's somebody that in the SNIA space that the Security Technical Work Group has interacted with quite a bit over the years. It's pretty routine for me to bounce an idea off of him and say, so what do you think about a technology that would do X, Y, and Z? And he'll go, well, is it available already? And I was like, no. So, but that kind of reaction is enough to sort of spook me. But I would say I'm being a bit facetious here, but I think even having conversations with lawyers who have some technology background, and there are a lot of them out there that are dealing with things like artificial intelligence and IoT, and they may not be dealing specifically with computational storage, but they've got enough technology background that they can ask you a series of questions and maybe give you some advice that's worth its weight in gold. Even though it's $600 an hour, it's close to the price of gold. But
well, let's switch gears for a minute. We have a question from the audience. Let me just read it. RDMA networks have to have a security component, e.g. distributed RDMA credentials, DRC. Can that model be adopted by the various storage vendors?
Well, I would say so. I mean, it's certainly part and parcel of what's going on, and has been largely, if you look at things like NVMe and so forth, the RDMA is already part of that, so that's already underlying it. In PCIe, you have some security and authentication and encryption going on there that's in process right now. So yeah, absolutely, I would say so. The important part, though, the important thing is that the connection that you have, rather than establishing this trust relationship, the trust relationship has to be something that you're establishing a trust relationship to, for example, download some code, right? Something you want to execute on this computational storage device. And really what has to happen in that case is both parties have to agree to it. So it's got to be bi-directional, right? So that I presumably you could do something similar to that. And I wouldn't be a bit surprised if we end up with something similar to that. But it's kind of a wide open topic right now.
Yeah, a computational storage drive is an endpoint that's connected to a network. So as we talked about earlier, that sort of approach will support the ingress egress of data movement, but there is the device level considerations that are over and on top of that, especially as you're opening up the compute engine on specific data sets. So I think it can fall within, but there's additional security concerns at the device level that also need to be considered.
Yeah, it's just not sufficient on its own.
Eric, you want to add anything to that, or have we kind of covered everything?
Well, I'll share what I was sort of ratcheting through some thoughts here. The thing that jumps out at me from a storage networking perspective is link encryption and how little of that actually gets used. It's been specified. So if you look at iSCSI, you've got IPsec. If you look at Fiber Channel, you've got FCSP and ESP headers. You should be impressed the security guy knows this. But how much of that does actually get used? And in the case of using ESP headers, so end-to-end encryption within Fiber Channel, good luck buying that, in a heterogeneous environment. So even though, but it's all specified. That's the thing that's a little worrisome here is so, the community has taken the time, agonized in some cases, to figure out how one would do this, right? But then the consumers of the technology don't have a requirement for it. So you get into this chicken and egg kind of problem where it's fairly expensive, it's fairly complex to implement some of this as a vendor or multiple vendors, where you've got interoperability issues you got to deal with. So unless there's a real driver, some sort of regulatory thing, or somebody's a first mover and it becomes their competitive advantage, unless you get in kind of one of those scenarios, some of the security stuff kind of gets thrown under the bus. And that's back to my early on comments. I'm worried about the security community not necessarily even aware of some of this technology, because without them, it's going to be hard for organizations to build up the drive that will then drive the vendors to do some of this. So that was kind of what I was chewing on there. So I'm just sharing with you that, and the link encryption piece is a really good example, because it's almost across the board when we look at the storage, but it's not because it wasn't specified.
Well, and I think one of the issues too that kind of comes up with that is a lot of that are being used by large enterprise customers. Some of the the guys doing that kind of stuff where they have other controls in place where maybe that's not as important. And by that, it could be, for example, a lot of times these hypercomputing environments and so forth are not on the network. They are local, they are maintained locally, and they have great physical security around, how you can access the drives, how you can access the systems, and so forth. So I think a lot of times in those cases, they just see that as a penalty. the security part as a penalty, because you got to do the encryption, decryption, authentication, all of that good stuff, when they don't really need it, right? They don't feel that the risk that they encounter because of the way they have their other controls in place is worth that kind of thing. But now when you get into broadly distributed storage, yeah, you're definitely in that issue.
You know, with the hyperscalers, the cloud service providers, they have the right to develop their own certification standards that says, okay, great, you have well, especially in IoT, you develop this accelerator device. That's awesome. I don't need to know how it works because you've already demonstrated the performance of that device. But unless it's certified under our policy requirements, sorry, it's not going to get into our infrastructure. So.
Yep. Yeah, and again, in the case of cloud, for example, we've already seen that there are international standards that are sort of driving those guys. And so when a customer comes in, I'm going to do some credit card IT here. They are asking, well, what's your position relative to the ISO 27017 standard? Which is dealing with information security management. And most of them will be able to basically respond. So this is kind of back where some of the high level standards will sometimes drive some behaviors on our customer base. But, the gap between something like 27017 and then some of the things that we're worrying about that might actually be plugged into what the cloud service providers are doing, that's not a little stream. That's a pretty big river you got to get across. And there's a lot of secret sauce in there, whether it's from the storage vendors themselves or the cloud service providers. I mean, we all have to sort of differentiate ourselves, and security is often not best when it's left to the back room. It's you gotta shine the light of day on it because somebody else is going to be inspecting it, and if you're not looking at it, with full transparency, full visibility, somebody else is going to be chasing it probably deeper than you are.
Yeah, there may be an opportunity here, whether it's SNIA or any of the other fine organizations, to really take the bull by the horns and develop these security standards and recommendations, whether it's in the architecture specs or standalone documents. And with enough groundswell interest in developing these requirements, I don't know if the cloud service providers will respond to it, but they'll certainly take notice. They'll take note. And I think what you were saying, it is a supply chain issue from the device through the subsystem of the drive, through the network, up to the host. So having that definition at the device level, and then ensuring that it's being shared with the CSPs at the beginning stages should help to move things along faster than if we had to react and bolt on security in a reactionary way.
Agreed.
Yep, me too. Agreed.
Well, panelists, we're nearing the end of our allotted time. Are there any closing thoughts that you want to offer before we conclude today?
Sure. I just like the opportunity to work with corporations, the startups, the agencies, the large companies, to take on this problem and address it holistically. I think it's an opportunity before we address the near-term business milestones that we need to meet. So I think there's an early stage opportunity to develop the right architectures that make sense for across the ecosystem. The competitive elements will follow; they have to. But I think we're still in an emerging state where we have this opportunity.
I would offer that especially with regard to SNIA, that there's a pretty healthy, robust set of security activities and engagements in place. So I mentioned several of the activities that are underway. There are representatives for most of those organizations engaging and collaborating, under the umbrella of SNIA. So they're either directly engaging the computational storage twig, or at least monitoring and standing by to see where they can help. And I think as things move forward, you absolutely will see guidance that will come out. And so, here are the things that are basically specified of what you could do and how you should do it. And I think what you're going to see from the security community is there'll probably be some guidance on it. This is exactly what you shall do in some cases, and here's definitely what you should be doing. So the good news is this is not going to be 10 years after the fact. You actually have some pool of industry experts dealing with storage security already engaged, and that's, I think, hopefully will be helpful.
And my only word would be to the vendors and to the end users of this product, especially larger corporations, keep security in mind. Really get involved with the security, because this is where it's getting defined now. You're not going to have a product without security in this day and age. I would strongly recommend that you take an active role in some of the SNIA security subgroup, for example, for computational storage. And also really, in the other standards organizations that I know some of the larger corporations work with, to really make security an important part of CS's introduction into the ecosystem. I think it's going to be extremely important. And I think we have a golden opportunity, as my other panelists have mentioned here, a golden opportunity to make it an integral part of this technology, which is really quite exciting.
Agreed. Well, thank you, panelists. That was a great summary. I appreciate that. So Eric Hibbard and David McIntyre and Walt Hubis, our panelists, thank you very much for joining us today and for providing all your insights. My name is Jason Molgaard on behalf of SNIA and PM+CS. Thank you very much for listening and participating in our panel.